Hey everyone, we're back with another conversation with Jim Miraflor, who we had last time talk about the history of AI and machine learning, which is a fantastic discussion. Welcome back, Jim. How are you?
Hi, okay lang. Kamusta?
Okay naman ito. Trying to get my head around all of these topics, no? Ang daming pwedeng pag-usapan.
Yeah.
So anyway, I think offline you mentioned you wanted to talk about the tribes of machine learning, which is an interesting concept, no? So yeah, kick it off, Jim, no? What are the tribes ba?
Actually, hindi naman yung original concept of tribes of machine learning. It was written by Pedro Domingos. Is a known machine learning researcher, one of the authorities sa Markov logic networks. Lately, naging controversial siya because of his some of his tweets. So, let's just set aside the person with what he proposed, and most of these discussions came from dun sa book niya, in The Master Algorithm. It's a very, very good book, 2015. And it was able to synthesize, the state of the art with regards machine learning. As I discussed earlier, di ba parang may machine learning is just a sphere within AI. And even machine learning itself is not it's not really a singular movement towards neural networks or the current dominant paradigm. It's actually divided into five tribes, so to speak, or five research efforts. And ang effort ni Pedro Domingos is to try to clarify each school of thought, and at the same time try to synthesize it into a master algorithm. It's his effort, but yeah, it's something that's okay to discuss. And then maybe after I discuss yung five tribes of machine learning, I'll seg a bit dun sa concept of an AGI.
Tama.
Basically,
Yeah, it would
yeah.
be interesting, no?
Basically, I want to, although kasi pag sabi mo kasing AGI, medyo maraming ibig sabihin. I want to focus on a specific mathematical formalism. I won't be delving too much on the equation, but specific formalism proposed by Marcus Hutter, yung AIXI, the Greek letter. AIXI kasi siya, pero it's actually a Greek letter. So pero AIXI na rin siya binabasa ng mga tao. So basically it's his formalism of a perfectly intelligent reinforcement learner. Right? So kapag sinasabi kasi nating machine learner, merong unsupervised learning, may supervised learning, and then may reinforcement learning. So his formulation is that of a perfectly intelligent reinforcement learner. And yun, that's how, yeah, I think yun naman, medyo mabigat na yung dalawa na yun, yung five tribes and yung AIXI. And yeah, maybe should I proceed? Ano
Yeah,
bang,
yeah, go ahead. I mean, kick it off.
okay,
I'm all ears now. Yeah, I
sige.
really want to delve into it. Lalo na yung mga pag pinag-uusapan yung mga tribes. I remember lalo na ngayon, no, when now that deep learning and large language models are all the rage. Funny enough, no, I don't know if this is just me. Some of the most enraged people about it are statisticians, no? Like I'm not a statistician, so I don't know if I can relate too much with what their angst is all about. But I surmise kasi it's all of these, I don't know, previously separate fields ngayon na-converge into one practice. So yeah, it'd be nice to hear ano ba talaga yung
Yeah.
mga tribes na yan.
Well, basically, yung mga you can subdivide it into five tribes in machine learning. So you have the symbolists. This is the closest to the GoFi, yung good old-fashioned AI, which we discussed earlier, yung mga physical symbolist, physical uh, symbol hypothesis people, na they still try to deduce intelligence or reduce intelligence into symbol manipulation and logical statements. So that's one big field na ang kanilang best product would be the yun nga, yung Deep Blue, din yung most popular product nila to as a statement. And then you have the connectionists. The connectionists, basically, ito yung ascendant ngayon. Ito yung hegemonic school of thought ngayon. The neural network people, which later evolved into deep learning. Deep learning because instead of just having a single layer of neural network, they put in more and more layers, hidden layers in their structure. So it has more predictive power. But nonetheless, they share the same philosophy, which is yung Hebbian learning, basically mimicking intelligence by mimicking the way how our neurons work. So nandiyan papasok yung
Can I ask a question
Mhm.
about that, no? Kasi I remember we were talking last time about yung mga schools of thought. So
Yeah.
clearly itong deep learning is an offshoot of the machine learning school. Uh do you recall what the inspiration was for yung evolution from the original perceptron into deep learning? Like I mean, it's so interesting how the intuition worked, na parang you had a single layer, and then suddenly by adding more layers, actually for some reason it captures more behavior information, no? Can you, rather than just making the single layer even wider, no? So I don't know, just thinking out loud,
Yeah.
do you have a point, you have a view on that, how that emerged?
Yeah, I mean, multi-layer perceptrons were already explored even before, even 1960s, 1970s. Kaya lang, they really have no efficient means to compute it. Kasi masyadong maraming it requires super compute. I mean, on those standards, on those tech, in that era, it's very computationally intensive, and it's not really feasible to test it out. So, but when there is this explosion of CPUs first, na they can do parallel computing, parallel serialized computing, it became possible to use it. I mean, to test the idea of a multi-layer perceptron, and there were interesting results. So parang from there, palaki na lang ng palaki at palaki pa sophisticated and pa sophisticated ng mga network structures until yeah, we ended up here na yeah, but even before, they knew na mas malaki yung expressive power of a multi-layer network, of multi-layer perceptron. So yeah, in fact they are already exploring some stuff like Boltzmann machines, mga yeah, in other constructs, mga based sa icing model, mga multi-layer stuff din na ngayon lang din talaga naging feasible, or at least recently, lalo la past 20 years na
Because
naging
of the
practical.
hardware
Yes.
development, no? Parang ganun.
Yeah. So yun, but basically it's actually a misnomer na it's still a neural computing when in fact it's more of a gradient descent type of yeah, kumbaga parang it's neural inspired, but the way it works is no longer that much related with how our brains work. Basically, it's more of uh, yeah, it's a more abstract notion. And yeah, so that's one. The symbolist, the connectionist, and then you have the evolutionaries. The evolutionaries are really those who are trying to use selection, the selective pressure over a set of programs, a set of solutions to a problem, mating them, combining them, yun, mimicking evolutionary process to end up with a good solution to a problem. And this is in fact still used. Later, I'll show you. I'll show sa ating listener na it's still being used in fact to design structures for neural networks. So it's still a very robust field, yung mga genetic algorithm people. And sa mga engineers, they still use it, yung genetic algorithm mostly. And then ito, yung sa mga statisticians, basically ang kanilang belief hindi lang sa machine learning per se, kundi dun sa mga Bayesians. Although mga statisticians din naman sila, yung mga Bayesians, they come from a different philosophy on what data is and what a parameter is. And but Bayesian, basically they see the world as you have a prior set of beliefs, and given an inflow of data, you use the Bayesian rule, the Bayes rule to calculate a new distribution of beliefs over that data. So and this is it is one of the more mathematically complex or medyo mathematically involved amongst all the schools kasi you just can't plug it in and use it. You might have to think about the model and how it works. So medyo it's not as popular, but yung kanilang mga ginagawa before, yung Mars rover for instance, they have an algorithm called Kalman filter, which operates using Bayesian, the Bayes rule. So they take in information, they filter it, and produce a model of the world. So still being used. And then lastly, ito yung medyo scattered na world, pero Domingos try to condense them. Yung mga analogizers. Basically, they try to create a theory on they try to condense intelligence as discriminating points in space, like separating hyperplanes across space. And when they do that, they are able to first distinguish related concepts from one another, and at the same time examine the resemblance of one concept to another. So parang you can, kumbaga, you it's not just that you can distinguish things, but you can resemble similar things na hindi mo pa nakita. Yeah, so it also involves some mathematical formalism. So kaya baka rin hindi siya ganun ka popular. But nonetheless, all of these schools are active, and maybe we can give the light of day for each para para mas ma-examine natin yung, I mean, mas ma-scan natin yung buong
Yeah,
world
for
natin.
sure. Now, you mentioned earlier about the Bayesian school, no? And obviously that's a branch of statistics, no? Can you talk a little bit about that, no? The Bayesians, the frequentists, and how that did both contribute to machine learning, or yung more of the Bayesian field lang?
Sige. So Bayesians muna. Usually parang pag describe sila ni Domingos as the Church of Reverend Bayes, because yeah, Thomas Bayes is actually a monk and a mathematician. So he came up with what we know as the Bayes rule. So basically, ang pinakakilalang application niyan is if alam mo ba yung Monty Hall problem ba yun, yung merong 3 doors, and then you're supposed to select one of the doors, and then when you select one of the doors,
Then the host will eliminate one. Hindi,
yes,
magkakamali ka muna, and then the host will
uh,
eliminate one. And then they will ask, do you want to switch parang doors, or
yeah, or
or
stick to your,
stick to your guess, no?
yes. Kasi parang, kumbaga, kung mostly mga traditional statisticians well, ngayon hindi na ganyan, pero parang to demonstrate yung power ng Bayes rule, basically ang intuition mo is hindi naman nagbago yung probability mo, right? Dahil nag-switch siya dahil nag-open siya ng another door. Kumbaga, it's still one third. Kumbaga hindi naman nagbago. Pero what you learned, according to Bayes rule, you should switch your door, particularly because you gain new information. And that new information actually increases your chance of winning. And that's because ang information doon is if yung door mo ay mali, then it couldn't have been opened, right? So, kumbaga, that's new information na yung door mo hindi siya yung hindi siya yung mali. Baka yung isa yung binuksan niya, yun yung walang price. So parang ganun yung Bayesian rule. So parang you change the distribution of your beliefs on what things are based on the new information. So you have a prior distribution of beliefs. You have, say ang aking prior distribution, yung die ko is fair, like 161616. Pero habang niro-roll ko siya, palagi lang lumalabas even number. So I'll adjust my distribution accordingly. So maybe it's biased uh, towards even number. So that's how it works. Yung concept na yon ng Bayesian updating, it's accepted in statistics even with frequencies. Ang nag-iba lang is how do you interpret it? How do you interpret statistical phenomenon? Kasi sa mga frequentist, parang you have a true value, right? And then you have a measurement, you have a sample that tries to approximate that true value. And that approximate, that estimate has a confidence interval, right? There's a confidence interval. Ang kanilang proposition is if I repeat this experiment, if I repeat this measurement infinite times, then there is say 95% chance that my confidence interval covers the true value. So ganun nila ini-interpret. Sa Bayesians, hindi. Parang sa Bayesians, ang kanilang interpretation is meron silang tinatawag na credible region na there is a 95% chance that the true value is in that credible region. Hindi siya repeated experiment. Kasi parang you update the distribution as you get more data. So that simple nuance, doon nagkakaroon ng mga debate even between statisticians and Bayesians. And much of machine learning actually is mas favorable sa Bayesian point of view. So baka doon nagkakaroon ng conflict. Nonetheless, this is a very important field. In fact, yung aking research, my personal research is on Bayesian networks, on creating dynamic Bayesian networks of economic and social phenomena and biological phenomena. So basically, what you have specific variables, say the probability of I finding a particular, say, a particular species in this particular location, right? Halimbawa, I'm an ecologist. I have assigned that there is a 5% chance that I will notice a tiger in this particular, or I'll observe a tiger in this particular area. And then something came in, like say a lion. I know na in yung tiger and lion, they don't naturally coexist. So dahil I spot a lion or I spot something, I would reduce the probability in my head, my belief that there is a tiger there. So ganoon din. Halimbawa, basa yung aking lawn, yung aking labas, yung aking hallway. Pero hindi naman umulan. So ngayon, i-increase ko na tuloy yung probability ko na naiwanan kong bukas yung gripo sa labas. So that's how Bayesians work
So it's an
basically.
iterative process of adjusting the priors and the
Yes.
posteriors, no? Yeah.
Yeah. So it's a probabilistic way of seeing the world. And yeah, it's a very up to now, it's still being used in fields like medicine na nag-a-assign ng probability for particular diagnosis based dun sa symptoms na nakikita. Kasi pag nakakakita ka ng bagong symptom, magbabago yung probabilities mo. Sa mga control systems, na kapag nakakita ka ng ganitong error, tataas ang probability na ito yung sira. Ganyan. So it's still an active and you learn the distributions based on data. So it's really still machine learning. So yeah. Medyo complex nga lang siya kasi yung the application of Bayes rule sa distributions, meron dong theory. Anong posterior distribution based on your prior distribution yung appropriate, yung mga ganun. So there is some math behind that. So medyo but still it's a robust field and it's still active.
Yeah, and a lot of people swear by it, no, as the better way of doing statistics, no. But yeah, syempre may rin yan, may schools of thought.
Yeah. Yung mga mga sa fintech, usually gumagamit sila ng mga Bayesian methods to estimate parameters, to estimate volatility na kumbaga parang I know that this particular index is more volatile. So therefore, ganyan na I should update my volatility estimate of these particular stocks kasi may dependency sila. So, kumbaga 'pag mas numeric, mas Bayesian yung ginagamit for yeah. But ang problem is yun nga, una, complex yung models and at the same time, it's very computationally intensive kasi, ah when you are trying to compute for the posterior distribution according to the Bayes rule, you have to divide it. You have to use as your denominator an integral, an integration of all possible scenarios. Ganun ko lang i-summarize. So basically, yung computation of that integral might be computationally intensive. They use other techniques like Monte Carlo sampling, Monte Carlo method to solve the integral, but it's what makes it computationally intensive, yung denominator. Otherwise, it's just as a matter of algebra. Lalo na kung ano siya, marami kang multiple case and then ang representation niya is a product. You just log it and then magiging arithmetic na siya. And kapag arithmetic na siya, mas less intensive sa floating point operations. So, yun. Sorry, it's a mouthful
No, that's good.
but it's
Actually, I was thinking about, well, clearly all of these tribes or all of these schools of thought predated, deep learning and machine learning. How do you see all of these schools now parang moving forward now that clearly machine learning, deep learning are quite popular? Kasi nga, there's a tendency, I'm talking about the progress in the field, no? Kasi I know there's a tendency for people to remain rooted wherever they started. Like usually nga statisticians and computer scientists don't get along from that perspective kasi iba yung grounding. They may be talking about the exact same phenomena pero through different lenses, no? So any thoughts about that?
siguro before I'm able to assess yung future kung maybe siguro I'll give some description do sa evolutionary yung sa other schools kasi we familiarize ourselves with the neural networks, the connectionists and the symbolists. Pero for instance yung evolutionary school, it's still used even by neural network people, and this is why. So basically, what they do is you represent a solution to a particular problem as a DNA of sorts or a string, and then you have random strings, random solutions to a particular problem, right? So and then maraming iba-iba. Some of them don't work. Of course, some of them are worse than the others. Some of them are actually the optimal solution, but you don't know. Maybe you don't even get to the optimal solution. So what they do is they mimic evolution by mating these solutions together, producing the next generation of solutions, and then testing it again dun sa objective function, which is yung performance. So based on sa performance, you call out the best ones and then you kill off the other solutions. And then you multiply the solutions again. Pero mas limited na yung kanilang characteristics kasi you've mated these solutions, yung mga previous solutions, so mas makakamukha sila. Right? And then you do the process for several generations until you reach a particular solution. So basically like for instance, ano siya sa mga problems na medyo mahirap i-solve like airplanes, right? So you're designing an airplane. So you'll be producing several designs and then you'll simulate them and then you'll see how they perform kapag if one particular performs worse than the other, and then you destroy that solution, you keep the other, and then you mate the several positive solutions or the better solutions, and then you iterate the process. Another application would be, halimbawa, you're solving a very complex set of equations, like yung BSP natin, Bangko Sentral, they have this model called dynamic stochastic general equilibrium, which they use to predict interest, predict inflation rates, predict unemployment rates. So yung mga predictions sila doon galing. But the calculations are non-linear, and it's very complex. So they use genetic algorithm to solve it. So basically, they just produce so many solutions and then they evolve them. So yung mga ganun. And for neural network, ito, kasi kung neural network ka, you'll have to design a particular structure, di ba? What network is ano? What network is appropriate for your particular problem? You don't know that. Kasi para ang tinitweak lang ng back propagation, for instance, yung main algorithm ng neural network. Ang tinitweak niya lang yung parameters, yung weights, right, ng mga nodes. Pero yung structure ng network, hindi yun nababago. Nababago lang yung mga weights. So, yung kung ano yung appropriate na structure, ini-evolve yun. Merong school of thought ng tawag.
It's kind of an art, right? Choosing the
Yes.
structure that works.
Yeah, that's ano, if you're selecting, pero merong mga practice na ang tawag is neuroevolutionary learning. Basically, you evolve the network. So you produce several networks, and then you test it. You learn the parameters, tas you play with them, and then call out the better ones, kill off the solution. Several generations that later you'll have the best network to represent a particular phenomenon. They use it to simulate, merong isang paper na kumuha siya ng AI for Super Mario and neuroevolutionary yung ginamit niya. Basically, it's not just enough na you have a Super Mario na merong neural network. Pero anong type of brain meron siya? Anong type of structure? Ano yung best Mario for that problem? Yan. In-evolve nung. So it's neuroevolutionary. So even Bayesians are yung Bayesian network. Diba ako nagpo-produce ako sa research ko, parang I tried to link kung paano nagbabago yung mga probabilities, like probability of spotting a particular coral if you spot a particular fish, and then you have a network of that, right, based on sa theory. But how do you end up with a network of dependencies? Well, it's still a structure, right? And I create the structure by evolving it by genetic algorithm. So yun, it's still some new deep learning people don't see the need for evolving the structures because they can always select the best structure. But it's an emerging practice na even the structure you evolve them. So that's for evolutionary.
Yung
And
evolutionary approach, kasi I remember I encountered genetic algorithm pero ang tagal na like during my banking days. You think it can make a comeback in the era of mga neural networks?
yeah, I think kasi for instance, like GPT, for instance, GPT-4 is a network with 1 trillion parameters, right? So it's a it's a very complex network. But in the race for good solutions with lower and lower cost, kasi you'll have maybe scarcer GPUs, so hindi pa mag-pan out yung quantum computing, for instance. So you'll have a particular physical constraint. Then there is an incentive to produce smaller networks to represent basically the same phenomena, and that structure can be generated through evolution. Yeah, basically yan.
Okay.
Anything that anything na wala kang clue paano i-solve, you can evolve it.
Doon siya mag-evolve, no? Yeah. Actually, even with the current Um, kunyari, the most current state of the art is the transformer network. No? And basically, um, it solves a problem of yung vanishing gradient issue with ano ba yung predecessor niya, mga recurrent neural networks, for example, or LSTMs. I'm wondering if there's probably going to be a new parang iteration on that no one probably currently understands. But I think one of the challenges that even with the transformers they're trying to solve is the computational load on hardware and software. I don't know if are there practices to address that. Like how do you I mean, siguro maybe hardcore mathematicians are the ones that figure that out. No? How do you find a way of solving for the same thing, but with a less intensive algorithm or a less computationally intensive algorithm? Is there such a practice of figuring that out?
Well, kasi, well, there is no particular network structure, for instance, that can efficiently solve all problems, right? So some network types might be better in solving a particular domain. Some would work on others. So parang there's no general solution. But maybe if there's progress, there is progress to be made with parang which networks would back propagation be easier, parang ganyan. And I think instead of although I'm sure all people have also figured it out, instead of thinking it theoretically, we can simply evolve we can simply evolve an appropriate structure na for that particular domain. So kaya yeah, ako tingin ko important pa rin yung evolutionary algorithm do sa pag-solve na yun. But I'm sure there are theoretical efforts to actually design optimal weights optimal weight updating, optimal weight tuning, etc. So yeah, but you can, I mean, the simple solution is simply to evolve them. Yun. Yeah. Ano pa ba? So yun, that's evolutionary, right? That's the evolutionary. And then the last, since we've already discussed yung symbolist and yung sa neural network the last time, yung sa analogizer, ito yung medyo mas mahirap, mas mathematically involved. Basically, if you imagine particular, sorry, I'm recalling from the top of my, if you are going to represent reality as an object with several features, say like a face. Ang face, meron siyang color, meron siyang shape, meron siyang weight, etc. Or whatever. Say a ball has a color, has roughness, has ganyan. So meron siyang several features. Those features can be represented as coordinates in space, right? And you are able to distinguish objects from one another based doon sa location of points na yun across space. Say for instance, meron akong I'm classifying houses. So merong size and merong price. So lumabas dun sa scatter plot ko na bagamat correlated sila. So merong scatter plot ng size at price para may dalawang clumps of points. So meron kang points na nandoon sa lower end na malaki, and then meron kang maliit na cluster. So para sa mukhang barbell. So the analogizer algorithm, say SVM or support vector machine or nearest network algorithms, they'll distinguish it as two objects. Like they will create a space, they will create a plane separating the two gaps. And then you extrapolate it across several dimensions. So isipin mo, hindi lang siya 2D scatter plot. 3D. So kapag 3D, instead of separating it with a line, not necessarily straight, so meron kang wiggles or meron kang function, you'll imagine as a plane, right? Kung 3D na. Kung 4D, you'll imagine as separating hindi na plane, parang surface, right? So ganon, and as you proceed with several dimensions, and there is a theory that on that na dinevelop si Vapnik, another Turing awardee, the support vector machine, na you can actually do that, and you can use that to distinguish objects from one another and see which objects resemble each other across this hyperdimensional space. Ginagamit itong SVM, ginagamit siya mostly ng mga statisticians, mga mathematicians to to establish resemblance, ganyan. Pero it's not yung kanya kasing original na application was to distinguish fingerprints and faces. And apparently medyo gumaling na rin yung capacity ng neural networks to do that. So parang okay, so medyo lumiit yung space ng mga analogize. But nonetheless, it's a school of thought na hindi neural network but producing separating hyperplanes to distinguish points in space. That's how they work. So yun, actually that's it. That's the 5 schools.
So si Pedro Domingos, when he wrote this, the context was to distinguish parang different perspectives around machine learning. And is there a way, is there an implied parang strategy? Like if you're one school, you want to beat the other school, or are the schools going to merge or diverge? I don't know, just thinking out loud now.
Well, nung umpisa meron talagang at least as late as 2015 there isn't a clear winner pa in terms of performance. So it's when he wrote it in 2015, so you can think of it as still as schools. Pero ngayon, moving forward to 2023, parang lumiit na yung analogizers. Tapos yung symbolists, yung iba na absorb sa neurosymbolic paradigm, kasi parang how do you produce the symbols which you will manipulate the concepts, you use neural network to cluster points together better than the analogizers, better than the support vector machine. So when you've created the concepts, then you can do symbolic processing. So may mga ganun sila, Gary Marcus, yan yung pinapromote it's neurosymbolic. Tapos yun, yung evolutionary, ganun din. May neuro-evolutionary school. Yung Bayesian updating, merong theory na merong mga papers which explains that the neural network itself is a Bayesian network. It operates like a Bayesian network. So in theory, it's analogous. So
Kasi
that's
similar, nag-update din siya ng mga weights, di ba? So
yes.
in a way, it functions like a Bayesian posterior or prior.
Yeah. So yun din yung kanyang na point na you can actually, and he is trying to attempt that through the use of Markov logic networks. Basically a combination of symbolist and Bayesian. And yun nga, since it functions like a neural network anyway, so it subsumes it. So meron siyang ganong proposal for a master algorithm. In terms of robustness, it's more like may mga domains siya may mga domains pa rin na kasi ang Bayesian school, it's very interpretable. I mean, it's hard to solve, but it's when you laid out the solution, when you laid out the model, you can interpret it that this variable depends on this variable, depends on this variable. But for neural network, medyo black box siya, di ba? So, yeah. So yun.
You mentioned earlier, so from the tribes, you had some perspectives about general intelligence, AGI. No? What's your thought about that?
Well, basically hindi tinakel ni Pedro Domingos yung concept of AGI. So that's another topic that I want to discuss. And one particular formalism, let me change my background screen para makita siya.
Yan.
Sorry para kasi ito yung screen ko, ayan, yan yung paano
I
niya
can see it.
distinguish yung mga
The,
school.
the schools of We should
Yes.
make that into like an infographic and parang spread it around, no?
Yeah, actually nasa book niya yan. So yeah. But for ito medyo alam ko sa mga pag medyo equation is very,
It's
intimidating. But
very scary.
yeah.
Sige.
But in essence, it's very simple. So basically, Marcus Hutter, a computer scientist, now based on Monash. I think Monash siya sa ngayon. Basically, they're trying to think of the most general way to express intelligence. And one of the clues that they've encountered is this notion of Solomon of induction. Basically, Solomon of induction is a generalization of Occam's razor. So, di ba pag Occam's razor, parang the simplest explanations are the most probably true, right? Yun yung Occam's razor. So, how do you represent it abstractly? So, you represent it abstractly as you have solutions represented as strings, right? Descriptions of the universe. You describe it, you have strings describing the universe. And then, you update that, you choose descriptions based on base rule, right? Pag meron kang bagong information, bagong evidence, you select the better solution, right? The better string, the better description of the universe. So that's how you update. But given similarly performing solutions, how do you select among strings among descriptions of the universe, among how do you select among equally good descriptions? Occam's razor, you select the shorter ones. You select the shorter strings. Basically, you select the simpler explanations. So that's Solomon of induction. That's what he's thinking. Na okay, maybe I can generalize this into describing AGI, into describing what intelligence really is. And he thought of it as a reinforcement learner. So sorry, ang dami ko ng mga terms Pero ang pag-reinforcement learner, basically, you do something, you get a reward, and then you update your action based dun sa reward. So halimbawa, may slot machine ako. Parang kapag pinupush ko to, talo ako palagi. So mas maliit yung ina-assign kong probability sa kanya the next time. Hindi ko na siya masyadong gagalawin. Dito naman ako sa kabila. And so on and so forth. So ganon. So parang that's reinforcement learner, right? So given that, I want a reinforcement learner which functions based on Solomon of induction. So that's his description of an AGI basically. So ito yung equation na na generate niya yung sa taas ko.
So it's like the underlying parang logic behind an AGI. Parang ganun.
Yes. So ano,
Has it been tested or is there a way of expressing
uh,
this in a, I don't know, software form? Just thinking out loud.
no. No, Solomon of induction is incomputable. So it's
Mm,
yeah, you really can't solve it. So parang pwede kang gumawa ng approximate
yeah,
AIXI agents. Pero it's a theoretical model basically.
sure.
Kasi you really can't solve across all solutions across time. So just to give an idea, kasi ako na-excite ako sa equation na to. It's intimidating but it's easy to explain basically. So you see the blue one, right? The summation 2 raised to the L, right? Ito. Yan, basically, that's the length of your description. Diba? When you try to think of your description, you represent it as binary digits, right? A tape basically. So meron kang ones and zeros. So yung length nun is that's the possible combinations of that string is 2 to the L, 2 to the length of the string. So halimbawa, you have a string of length 3. You have 8 possible combinations of that string. You have 4 length of a string of length 4. So you have 2 to the 4th, 16 possible combinations. So you prefer the shorter strings, right? Kaya nga siya negative. And you compute for the length by inputting a program queue. That's your Turing machine, basically. What Turing machine gives me the best description of my universe, and what is and how short it is. That's your parameter. So yung queue na yun, that's what you use to compute for your utility function. Ito nasa baba, itong U. Yung utility across actions A1 to AM across time, for time A1 to time AM. And then from there, you receive rewards R1 based dun sa state of the universe O1 across time. So parang it looks forward to the future. If I do this, ito yung mga rewards ko, pero given that state, kapag ginawa ko naman to, ito yung reward ko. So para meron kang path to the future na sequence of events na prediction mo. Yun. Tapos, minamaximize mo lang yun, yung utility mo across time, across all possible actions. Kaya siya ganyan. So it's very simple. It's a very simple description of what AGI is. And it just says na an AGI is an agent which selects the shortest possible solution that can best yield a future reward, set of future rewards. So,
Yeah.
very, very simple, and it's
Very
very
reinforcement learning-ish, no? Parang gano'n ang
yeah.
dating eh. Parang, okay.
Yeah,
Yeah,
but
fascinating.
kumbaga, on top of being a reinforcement learner, it's Solomon inducer. Kumbaga, parang it selects the simplest explanations.
Mm-mm.
Kumbaga, it's
Mm-mm.
not enough that you have better rewards, but you have to give priority to simpler explanations, to simpler programs. Yun.
You know what's very hard to model. I mean, yeah, obviously this is a good a good theory no, to cover it. Is when you look at supposedly intelligent humans who don't necessarily do the most optimal outcome, no? Or for example, the cons in balik tayo sa language kasi we talked about language last
Mm-mm.
time. Parang the concept of sarcasm, hirap
Mm.
i-model eh, di ba? Kasi you say something that looks happy pero actually you're not happy. Parang it's a deception. Yun, the concept of
Yeah,
deception.
exception.
Unless deception is modeled as a process. I don't know. Kaya, for example, yung mga fears nila of misaligned AI is basically the AI's objective function running contrary to some process. Like parang the simplest one I can think of yung there's this case of a robot driving a boat around the racetrack, no? I use that as an example. Pero yung objective niya was maximize your high score. And the high score is not dependent on the racetrack. Baga, may mga bonus items siyang kinuha that keeps respawning on the game. So, dun na siya na-stuck. He just kept on picking up the bonus items
Mm.
to achieve the objective. Pero yung yung mga aligned outcome should be finish the race. So that's an excellent example of kumbaga the alignment issue eh. And yung mga safety people they divide it pa nga into inner and outer alignment. So tama, maximize niya yung kunyari gagamitin niya tong Solomon inducer. Solves for the objective, shortest path, pero doesn't necessarily arrive at the aligned outcome, no? Maybe that's a second equation siguro or something na
True,
somehow
true.
it minimizes the distance between the outcome and I don't know, the value or
Yeah.
the principle or the philosophy behind it, no? So it's fascinating. Na actually parang bumabalik tayo sa symbolic AI era kasi it becomes a
Mm.
rule sort of a rule-based strategy rather than just an optimal parang calculation. Maybe a
True, true.
fusion of both. No? Interesting.
Yeah. Actually, dun sa ano, I mean, kung sa mga AI alignment people, they always talk about yung the paperclip, paperclip maximizer.
Mm,
So, yeah, it's for those who don't know, sa mga listeners, you design a machine that creates
creates paper clips.
paperclips, and then because you didn't align it, the algorithms dun sa, I mean, what is morally feasible, morally possible, the machine ended up transforming everything, the whole world into a paperclip machine.
Mm,
All
mm.
yeah. So parang ganun din. Ito kasing AIXI, meron silang simulation na ginawa na parang since it tries to um kumbaga create options, right? Kasi yun yung kailangan niya malaman yung kailangan niyang makita yung entire space of solutions. Yun yung isa sa mga constraints niya eh. So it ended up hurting itself just to know more about its environment. So
Yeah.
it's a suboptimal, kumbaga
Outcome.
kung human way, in human thinking, hindi yan yung hindi
It's
yan
not what we
yung
want. It's
what
not
we
what the
want.
humans want.
Oh, although human beings do that, di ba?
Yeah.
They hurt themselves trying to know their environments, like
Oo.
explorers, for instance. But yeah, you have to have a separate equation. And of course, ito pang problem. I mean, saan galing yung reward function?
Mm.
'Di ba? Parang hindi naman siya a priori na meron kang gusto na ano ba ikaw, alam mo ako, I like spicy food because I was exposed to previous spicy foods. Like so I'm optimizing my food intake based on spiciness, for instance. But where did that come from, 'di ba? We don't know. And that's another problem kasi walang yung selection ng objective function, hindi siya dire-describe nitong reinforcement learner.
Tama. Tama.
May mga ibang attempt na on physics side, merong yung causal entropic forces. Parang basically, 'di ba, second law of thermodynamics, a closed system would increase its entropy. Parang do sa causal entropic forces, parang an emergent property of a system would also increase its entropy. So parang assuming na yung intelligence is actually complex behavior. So intelligence is a measure of how much you increase the entropy. So and interpreting entropy as information, the agent that is controlled by causal entropic forces would be one that maximizes options. So parang yun ba yung ultimate reward ng mga intelligent beings, na to experience as much as possible? That's one philosophical implication of that.
Correct.
Kasi yun ang kumbaga, yun ba yung reward function na pinaka-objective na reward function na experiencing everything? For some hindi naman, 'di ba? Parang I mean, enjoying what you already
Yeah.
have.
Well, maybe the word experience is relative. For some, it's pleasurable. Yung iba naman, it's not necessarily all about pleasure. Sometimes it's also about pain.
Yeah.
And sometimes it's not intentional. Or you say it's not intentional, but actually it's implied. Yeah. So ang daming dimensions pa na kailangan i-model for those things. No? Like sometimes I don't even know what the ultimate outcome of a human is, other than to, 'di ba? Parang
Yeah.
staying alive, I guess, is the bottom line. Pero kaya malaking bagay talaga if you encounter people who are basically suicidal. That really reflects a dysfunction in their objective function. No? But for the rest of us, I don't know.
Yeah.
Parang other than staying alive, I can't say if people are here to maximize happiness, maximize and by proxy anything related to happiness, wealth, power,
Yes.
influence, fame. That's one function lang. Eh. Pero yung iba pang function, hindi mo masabi. Eh. Some don't want to pursue that, no?
Yeah.
Or iba motivated by other things. So, or some don't even have a motivation
Yeah.
other than to survive, no? Yeah, it's amazing. Okay.
Yung sa causal entropic forces, it's to maximize entropy. Kapag we
So it's
are
the
intelligent,
opposite. It's the
yeah,
opposite. You
that's our
wanna
purpose. to drive
basically
us closer to the heat death.
you wanna wreck everything, no? Actually, may ganung concept nga din eh. Parang uh because if you don't have that, parang if you think of everything as a complex system, no, there's always that one I don't know, anthropic agent whose main purpose is just to wreck everything. And then it inspires the rest of the system to defend against that, no? So yeah, parang ang ganun. It reminds me of yung conversation ko with Miguel de Guzman and Ben Tehanki recently on AI ethics. And it's kind of a philosophical version of it. Parang we appreciate information better if there's a story behind it. So if there's a villain and a hero, parang conceptual protagonist antagonist perspective. Gumaganda yung flow ng kwento. It becomes less boring, it's easier to remember. So maybe that's an analogy for this entire anthropic system that we need to contend with, no? And machine learning is basically the activity that minimizes the entropy as much as possible or maximizes the, I don't know, kung ano man yung objective function mo, no? Whether to minimize error or maximize likelihood or reduce entropy, mga ganun.
Well, yeah. Well, kasi syempre, when you think of information, basically there's this interpretation that information is negative entropy. So parang yeah, it's a different. I mean, we will feel an hour more than
We
to
need to do
discuss that.
another
Yeah.
episode, no? To talk about that, no?
Yeah, but yun, parang entropy is not necessarily bad. Kumbaga
Mm.
parang meron nga mga algorithms na maximum entropy yung
Mm.
because it's the more entropy, the more things you can describe in your environment. So yeah, I mean it depends on the function, the algorithm that you're using.
Yeah, even the notion of explanatory variables or interpretable variables is related to that, eh. You won't know until you do relative measurements. You won't know until you do. Kaya nga which is another parang rabbit hole of its own, no? The difference between causation and correlation. And there are studies, diba, about causation models, causal models, which in a way are just fancy ways of reinterpreting correlation. Parang you're just making sure na it's closer but not exactly there to a causal relationship. In a way, that's an information problem then. When you find the causal relationship, by definition, you've unearthed the information, or you've I don't know if it's maximized or minimized the entropy around that relationship. So yeah, it's
Magandang
amazing.
reading dun yung I mean, kung sa mga yung kay Judea Pearl, Book of Why. It's
Book of Why.
very, yeah,
Okay.
it's very layman friendly. It's a good book. I mean, I would recommend it to everyone.
Sige,
Yung
kunin ko
causal
yung link niya na I'll
models.
share it with the group when later after this conversation. Book of Why. Hanapin ko
Yeah.
na nga.
Si Judea Pearl is another Turing awardee. So,
Hmm. Okay,
but
sige. Well, almost at the hour again. So
yeah,
this is really pag maganda talagang topic, it's easy to burn time, eh. So just to kind of summarize this entire conversation around, we talked about the tribes, we talked about AGI. Any parting thoughts for our listeners? Especially though, actually, okay, one of my intentions talaga for having these conversations, apart from, I guess, indulging people who like AI and mga related concepts, is to get more people interested in it. No, the whole point is not to intimidate people, but to, in a way, convince them that it doesn't need to be painful. No, obviously, people need to study something, if they want to do this, whether they end up building models or using models. Pero it's good to understand kind of the parang what's under the hood, of all of this AI. So any thoughts about that? What how you would encourage people to get into the field?
yeah. But siguro I mean kasi you always begin with the concepts, right? When you understand the concepts, the methods would follow. Kasi kapag when you start with learning the methods, of course you'll be able to produce specific things that will be of use. But sometimes it might not be the appropriate tool for that particular purpose. Or if you just know of a particular method, diba? If all you have is a hammer, everything would look like a nail, right?
Yeah, for
Right.
sure.
So that's the analog of that. So when you examine just the methods, or a limited set of methods, without examining the concepts, your capacity to do stuff correctly and accurately, or to solve a particular problem, would be limited as well. So I encourage everyone to peek under the hood. I mean, to look at all of these progress, not be intimidated with the math. Kasi math is just a language basically,
Yeah.
to express as brief as possible a particular phenomenon. So read the verbalized version of those equations, and
Mm,
you'll
mm.
understand it better.
Oo nga, and I think the biggest chunk of it is the notation. It looks intimidating, but once you understand what these symbols mean, it's just a way of abbreviating a sentence, no? And then another life hack I also realized is, especially in my case, no, I don't come from a mathematical background, although I took accounting, just sort of mathematical. Now, I got exposed to the application of it first. No, in my case, no,
Mm.
I used the models, I used the software, because it was mostly on the job, and then that inspired me to look into the calculus, the algebra behind it. It seemed, for me at least, less painful that way. Pero kasi the way we teach these subjects, nauna talaga yung formalized math, no? And there's a big knockout. Like I experienced
Yeah.
this when I was helping write the master's degree in UANP, no, for analytics. And the target of that was not necessarily technical people only. It should apply equally to both. I gave that input to them na, hey, look, we definitely need math in the curriculum, statistics in the curriculum, certainly programming. I don't think you can get away with it without it. But maybe it's the sequence of events that you need to
Yes.
manage. No,
Yeah.
obviously the more mathematically mga STEM inclined, I don't think they have a problem. But those coming from humanities, maybe to a certain extent, the business, the economic side, uh, it's the sequence by which you absorb the information. Eventually, everyone ends up in the same place, no? Which is using all of these fantastic tools, hopefully
Yeah.
for good. So
Um,
anyway,
just a word on that. Ang problem din kasi is most people, since they're so enamored of the math, they just start with that, right? I mean,
and
sa
end
akin
with it.
dapat,
Oo nga.
you start with the concept. I mean, what
Mm,
what is the math trying to model? And that will make the math easier,
tama,
right?
tama. That's actually one of the. I think I mentioned this in one series I want to run, maybe in I don't know, maybe a week or so,
Yeah.
is to just demonstrate what's happening under the hood. Kunyari, when you run a gradient descent, or you run uh, a root mean squared error minimization process. It's easy kasi to just take it for granted. Eh. Okay, you click a button, pak, you got the answer na. Pero it's a series of iterations, eh. And lalo na now that we're dealing with very complex architectures, really a good intuitive understanding of what's happening inside needs to happen. Um, and then people kind of, well, apart from they're less intimidated, they begin to get an intuition also of how it works. And you kind of know now, okay, I kind of know why that answer came out. It's because we have outliers in the data and the way the calculation works. That's another thing that throws some people off. If you're looking at a stochastic process, sometimes you don't get the same answer twice. Sometimes it's
Yeah.
a different answer, no? Generally within a range of parang distribution. And ganyan din yung large language model. You don't get the same answer twice. It's approximately the same sentence if you ask the same question again and again. Um, pero yun na nga, it's within a range of outcomes. And within those outcomes, I think the tricky part is when some of the outcomes become non-factual and some of them
Mm.
are semi-factual or true. That's when things get tricky, no? Maybe we keep that for another time now when we have our third discussion. Okay.
Okay.
Sige, thanks Jim. I
Thank
appreciate
you.
it. And yeah, hope to get you on another conversation.
Yeah, I'll try to make myself available.
Okay.